Everyone was confused today when we went over parallel lines and perpendicular lines, so we're just going to break it down for you one more time. So a lot of times questions will ask you to find the equations of parallel or perpendicular lines. So we need to know a few things. Parallel lines look like this. They never intersect, and they have the same slope. So when you're writing the equation of a line that's parallel to another, you're just going to use the same slope you used in the first equation. Okay, perpendicular lines. Perpendicular lines are two lines that cross to form a 90-degree angle. They look like this. The slopes are negative reciprocals. So, if the slope of the first line is 5, you have to turn the number into a fraction. That's the first step. Then flip the numbers. So the numerator becomes the denominator becomes the numerator, and then you change the sign. So this becomes negative. So first step, make a fraction. Second step, flip the numbers. Third step, change the sign. Okay, easy enough, right? These are the two things that you need to remember in order to do parallel perpendicular line problems, okay? Parallel lines, same slope. Perpendicular lines, slopes are negative reciprocals of one another. Okay. So let's do a few practice problems. This problem is on page 75, which is part of your homework tonight, and it's number 2. So the question asks you, all right, so we're given this information. Find the equation of a line that contains A, negative 3, 4, and that is parallel to CD with C, and they give us the coordinates of CD, line CD, okay? So first, just so you get an idea of what we're working with here, I'm going to try to graph the given information. Okay, so C is here. D is here. We're looking for the equation of a line that contains A, which is right here, that is parallel to CD. So the equation of A is going to look something like this. That looks really horrible, I'm sorry. So the first thing we need to do is find the slope of CD. Okay, so we're going to find the slope of CD. The equation for slope, m equals y2 minus y1 over x2 minus x1. We have x1, y1, x2, y2, okay? So m equals y2 is 1 minus 2 over 3 minus negative 3, which gives me a plus. And I get negative 1 over 6. So my slope equals negative 1 over 6. Okay, so I need to find the equation of a line that contains A, but is parallel to CD. So we know that parallel lines right here, always have the same slope because they never intersect, right? So I need to somehow use this slope here negative 1 over 6 to write my new equation. So I'm going to have something like y equals negative 1/6 x plus b. So I need a coordinate in order to solve for b. Luckily, the problem up here, it says that the line contains a, which is negative 3, 4. So that's great. We're going to plug in negative 3 and 4, which are an x and a y value, into the equation down here. I'm going to get 4 equals negative 1 over 6. X is negative 3 plus b. So I get 4 equals negative 1 times negative 3 gives me positive 3, divided by 6 gives me 2. So I get 2, oh, I'm sorry, hold on. Let me write that out. Negative 1 times negative 3 gives me positive 3, divided by 6 gives me 1/2 plus b. So I'm going to put everything over 1 so I can do my denominators. And I get 24 equals 3 plus 6b minus 3 minus 3. I get 6b equals 21 divided by 6 divided by 6. B equals, let me do a calculator real quick. 21 divided by 6. 3.5. Okay, great. So now that I have B, and now that I have M, I can write my equation. And I get y equals negative 1/6 x plus 3.5. And that is the equation of the line that contains point A that is parallel to CD. All right, let's do another example just so you're more familiar. On the same page, we're going to move down one and we're going to do, so if we look at this question, we want to find the line that contains W, which is 6, 5, that is perpendicular to DE, with D being negative 2, 1, and E being 4, negative 2. All right. So we'll make our little XY coordinate. Okay, so D, ordinarily we wouldn't be graphing these, but I think that a lot of us struggle with perpendicular lines, so I just want to show you what this line would look like, okay? Alright, so this line is DE. Alright, so let's find the slope of DE. Slope equals y2 minus y1 over x2 minus x1. Let's label our points. We have x1, y1, x2, y2. Excuse me. So m equals y2, which is negative 2, minus y1, which is 1, over 4 minus negative 2. This is going to give us negative 3 over 6, which reduces to negative 1/2. So slope equals negative 1/2. Now, the slope of this line, DE, is negative 1/2, which makes sense because remember Mr. Slope Guy? Lines that go down like this have a negative slope. Okay, great. So we're looking for a line with a positive slope that passes through, wait, hold on, that passes through the point 6, 5, right? So we're probably looking for a line that's somewhere over here. It's going to have a positive slope, and it's going to intersect at 90 degrees. That's the definition of perpendicular line, okay? All right, so the trick to find the slope of a line that's perpendicular to another line, we take the initial slope of the first line, we switch the numbers, switch the numerator and the denominator, you get -2/1, and then you change the sign. So we're going to get +2 is the perpendicular slope. Okay, so there's 2 steps there. First, make sure it's a fraction. So if this wasn't already a fraction, we would have had to put it over 1 in order to make it a fraction, but it's a fraction. Then we flip the numerator and the denominator, and then we change the sign. Okay, so those are the 3 steps you have to do in order to find the slope of a perpendicular line. Okay, so I'm just going to erase this real quick so we can have enough room to finish the problem. So the new slope of the perpendicular line is 2, and we are given the point 65. And we totally know how to calculate this equation of a line given slope and a coordinate, right? So y equals mx plus b. We have the slope, which is 2. We have x, which is 6, equals 5. We have 5 equals 12 plus b. All right. Minus 12. B equals -7. So the slope and the equation of the line that is perpendicular to DE is y equals 2x minus 7.